Review section 7.5, similar triangles. We've already reviewed angle-angle similarity. That's when you have to show that you have two pairs of congruent angles in order for the triangles to be considered similar. So if angle A is congruent to angle D, for example, and B is congruent to angle E, then I can show angle-angle similarity. Sometimes you might be asked to state the similarity of the triangles. What that means is to write the similarity statement in the correct order. So triangle ABC would be similar to DEF. The reason would be angle-angle similarity. The new theorem we're going to learn is side angle side. It's very similar to the congruence postulate. For side angle side similarity, you need to show that you have two pairs of proportional sides. So let's say this was 8 to 16 and this was 10 to 20. Well, you notice that both pairs of sides reduce to a 1 to 2 ratio. That's also the scale factor. In order for SAS to hold true, the angles between them have to be congruent. If you remember in angle, angle, the angles were congruent. So angles are congruent, but sides are proportional. Sometimes I mark the pictures like this just to help me keep track of the proportions. So SA is to BR as AM is to RI, and angle A is congruent to angle R. So therefore the triangles are congruent. So SAM is not, sorry, the triangles are not congruent, they're similar. SAM is similar to BRI by the side angle side similarity postulate. Theorem, excuse me. So SSS, similarity, all three sides. So say this was 8, 16, 10, 20, 7, 14. You notice here that all three sides are in a 1 to 2 ratio. So if this triangle were ABC and this one is XYZ, then you notice that AB is to XY, 8 to 16 reduces to 1 to 2. BC, 10 is to YZ, 10 to 20 reduces to 1 to 2, and AC is to XZ, 7 to 14 reduces to 1 to 2. This is enough information. This would be like in my given or something that I'd have to prove, and this would prove that triangle ABC, so that's how I state the similarity. It doesn't always have to be alphabetical either. You could have said BAC and YXZ, etc. They're similar by SSS similarity. Okay, so let's do some examples. So here on the next page, I'm just going to include, if you can pause it to try to figure it out on your own. But if you look, in this first, yes, they are similar. In this one, yes. This one is yes, and this one is no. I'll go back and explain. If you look here, I have a pair of angles congruent. So that's enough for the angle part of the SAS. But I have to show that I have two pairs of proportional sides. If I look here, these two sides are congruent. Let's make up a measure. Let's say it's 5 and 5. Let's say here it's 6 and 6. If I notice when I compare them, 5 to 6 equals 5 to 6. So yes, they are proportional. When I look here, I have the angle. Angle I is reflexive. Angle I in the little one is the same as angle I in the big one. So 5 is to 11. If you look, 5 plus 6 is 11. This whole side is 11, as 5 is to 11. By the way, they don't have to always be isosceles. Okay, so they just have to be in the same ratio. So IAN is similar to triangle IRZ by side angle side similarity. When I look at this one, it's yes, because if you look, this is isosceles and the other triangle is also isosceles. Because of the isosceles triangle theorem, we know that the base angles across from them are congruent, which means that they both have to be 60. So right there, then and there, I have enough to use angle-angle. To show SAS though, well, two angles, they sum to 120. When I subtract that from 180, I get 60 degrees as the third. You actually notice that these two triangles are equilateral. Equilateral triangles are always similar. That's a nice little shortcut. They're similar to each other. Okay, so like if you have a pair, they are similar to each other. Okay, so if I look here, well, it almost looks like they'd be similar, but it's a no. Yes, you have a pair of angles, but if you look here, the matching correspondence, SAS, it has to be the angle between the two sides. If you looked, I don't know the measure of OL, okay? Don't let it fool you. Yes, 5 to 10 is 1 to 2 ratio, but look at the order. The order matters. If I look here at the next slide, so let me give you some measures. I didn't give measures here. Let's say this is 10, this is 15. Let's say that this is 15. Actually, let's say that is 5. Let's say that this is 20. Let's say that this side is 15. Let's say this side is 30. Okay, so to find the similarity first, let's try to find what the scale factor is. What's the smallest side in this triangle? You can't go by just how it's drawn, okay? You gotta compare the smallest sides, the medium sides, the largest sides. They will line up in accordance to the similarity. So the smallest side here would have to correspond to the smallest side in this triangle. In this case, that's 15. So 5 over 15. Let's see if that equals, what's the next side? 10 to 20. And the next side would be 15 to 30. So let's check it. 5 to 15, that reduces to 1/3. 10 to 20 reduces to 1/2. Uh-oh, those aren't equal. 15 to 30, that reduces to 1/2. All three have to be equal in order for it to be side, side, side similarity. Okay, the scale factor has to be consistent. So this is a no. Here we have 3 for the small side, and here we have 9 for the larger. Here I have 5 for the small side, I have 15 for the larger. And well, actually for this one, you know that if you had the angle, you could use SAS, but let's just look at the sides. 6 to 18. So 3 is the smallest, 9 is the smallest in the other triangle, 5 is the medium side, 15 is the medium side, and the larger 6 to 18. Let's see, do they reduce all to 1/3? Oh yeah, so SSS similarity. Here, remember in the previous page, I told you that equilateral triangles are similar. If you notice, all the sides would be in the same ratio, so this would be a yes. And in this one, let's say you get a picture that, let's say all you're given is that they're right angles. Well, all right angles are actually not, they're not always similar. So this is not enough information. We'll just say no. Okay? When we look here, name 2 similar triangles. So you'll actually get something like this on your homework. So let's take a look. Okay. So if I give you this picture, and let's say these two sides are parallel, well, you know that you could then use angle-angle similarity. And how did you know they were parallel? I just told you. Okay, so let me say I gave it to you. You know that those are congruent, those corresponding angles are congruent. You could even see that reflexive angle. If I look here, well, you have that that's not reflexive, that's a vertical angle. Some of you have been making that mistake often. This is a vertical angle. Okay, so let's see, 10 corresponds to the smallest side here, to 20, and 15 corresponds to the larger side, which is 30. 1/2 equals 1/2. Awesome. So I'd have to say triangle DNA is similar to triangle LNY. Here I have parallel lines, so let's try to find some angle relationships. So if I look here, parallel lines in this transversal, then I have a pair of what we call corresponding angles. If I look the other way around, you have another pair of corresponding angles, and then I could use angle-angle similarity. If you look at these problems, you want to first find out the scale factor, but you have to figure out if they're similar. What I like to do is just size order, find this from small, medium to large. Okay, smallest side is 6, smallest side here is 9, 6 to 9. that reduces to 2/3. Medium side, 8 to 12. 8 over 12, that reduces to 2/3. The largest side, 10 to 15, that reduces to 2/3. So yes, it's similar. It says AB is to TR as BC is to RI as AC is to TI. When it says write the similarity, it wants you to write that statement. So AB is to TR as BC, so I would say BC is to RI as AC is to TI. So that's, I would write ABC is similar to TRI. Here, let's do it again. So, like I said, my trick is small, medium, large. So, small list side here, so 3 to 18, reduces to 1/6. Medium size here is 4, and the medium side here is 22. 4 over 22, that reduces to 2/11. So, this is already not equal. Okay, scale factors have to be the same. Before I actually did it, so before the scale factor was 2/3, here the scale factor, there's none because they're not similar. If you want to do this proof, you can pause it and try it on your own. I'm going to show you how to do the proof. So looking at the picture, I already see that I have angle A between, let me just write my given out. But angle A in the smaller triangle, ABD, is the same angle A that's in the larger triangle, ACE. So I can say they're congruent by the reflexive property. Then I have that the two pairs of sides were proportional, so AB corresponds to AC, AD corresponds to this, so I have SAS similarity. And then for the last one, you're given that all three sides are, so MA corresponds to WE, AX corresponds to EL, and MX corresponds to WL. So you already know, just looking at that, looking at what you were given, that the two triangles are similar. I was given all three sides, three pairs of sides, the proportions, so that would mean that triangle MAX, naming it is important in the right order, WEL, are similar by SSS similarity. And angle A would then be congruent to angle E. So think of this as like, you can't say CPCTC because we're not proving anything congruent, like the triangle's congruent. But if you remember, if triangles are similar, that means that all of their sides are proportional and all of their angles are congruent. So the CPCTC equivalent for similarity would be the definition of similar triangles. Okay, so I'm going to end there, and good luck with your homework.